Hi everyone, thank you so much for being connected today. Today I'm going to give you an introduction to Lightning Web Components. I'm going to do that from a practical approach perspective. My name is Alba Rivas. I am a lead developer evangelist at Salesforce, and this is my Twitter handle in case that you want to contact me later or ask me questions or whatever you need. This is a forward-looking statement slide. We include this because Salesforce is a publicly traded company, and what we mean with that is that you should make purchases based on the functionality that is generally available. And with that, we're going to start. First, I want to give you an introduction explaining what Lightning Web Components is and why do we have released Lightning Web Components. Lightning Web Components is our UI development framework. It was released in January 2019. It's been there for a year now, and is our preferred way to create a front end for our applications. To understand why we released this framework, we have to take a look back at the previous years. If we take a look at this picture here, we can see a graph that represents the web standards evolution during the last years. You can see that from 2014 until now, the curve is very steep. This is due to the fact that two organizations have been working together on the elaboration of web standards and standardization of them. Those two organizations are the World Wide Web Consortium and the ECMAScript Technical Committee. Salesforce is part of this second organization. So now we're in a situation in which those web standards have evolved. Most of major modern browsers support all those evolved standards, web components standards, and we can create a new generation of frameworks which are super thin because most of the functionality is already performed by the browsers. For that reason, we have created Lightning Web Components. So Lightning Web Components, if you take a look at the picture, is the part represents the part in blue. So the part in orange is what the browsers already support, and the part in blue is the functionality that we have implemented in the Lightning Web Component framework. There are mainly four things. So first thing is that we have abstracted the most complex part of the Web Components APIs, and we're going to see that in a second. Second, we have implemented a secure environment. If you write Lightning Web Components, those are going to run in a secure environment, and you are not going to have to worry about vulnerabilities or attacks, right? Also, we have created a data service that makes very easy to retrieve or modify Salesforce data, right? The communication with the backend. And we have provided a library of pre-built UI components, which is our base component library. Web Components specification is mainly built of four inner specifications, right? And I'm going to explain what they are about, because I want you to get away from this talk with the idea that almost everything that we use in Lightning Web Components is standard. Lightning Web Components are mainly written with HTML, JavaScript, and CSS. And if you learned JavaScript a long time ago, it was my case before starting with Lightning Web Components. When you start seeing Lightning Web Components JavaScript, you may think that that's something proprietary, that's something that Salesforce has invented, but that's not true. What happens is that the JavaScript language has evolved a lot with the time, and I'm going to demonstrate you that. So the first specification that is part of the Web Components standard, and I want to talk about is the HTML templates specification. This specification defines how to create reusable pieces of markup, as we are seeing here, right? And insert those templates dynamically in the DOM at any point by using JavaScript. So these templates and template keywords are going to be familiar when you work with Lightning Web Components, because each Lightning Web component is going to be defined by a template. However, you are not going to have to worry about the syntax for inserting that into the markup, because the framework takes care of that for you. The second specification I want to talk about is the custom elements specification. I'm sure that you know some standard HTML elements as div or span or anchor link or a lot more, right? It happens that according to this specification, you can create custom HTML elements that can be reused within your markup. This is an example of how to create a custom HTML element, which is called flag icon. This would be its definition in JavaScript. This is the behavior of the component, right? And here we can see the word class. This is because in JavaScript, in the newer version of JavaScript, we do have classes, right? And we can see that this class extends the HTML standard class. We are going to see something similar in the definition of our Lightning Web Components. When you define a custom element, then you can use it as if it was a standard one. For example, here we are seeing a usage of the flag icon component. Then we have another specification, which is the ECMAScript 6 modules specification. So the JavaScript I learned in 2005 was that one previous to the ECMAScript 6 version. Now we are on the ECMAScript 6.9, but the truth is that the version 6 included a lot of improvements for the language. And one of these improvements is the ability of using modules. By using the JavaScript modules, what you can do is to define reusable pieces of JavaScript and mark them to be exportable. That means that in all the different files here, for example, you could say, I want to import this function from this JavaScript file here and use it here. So it's a way of modularizing JavaScript. And we're going to see as well that our Lightning Web Components are normally JavaScript modules. And finally, I want to talk about the Shadow DOM specification. This one is normally the most difficult to understand because it's a more advanced concept, I think, but it's probably one of the most important specifications, because thanks to these specifications we are going to be able to have components that are isolated, that are encapsulated, and that are very secure, right? So this specification explains that instead of having a single document object module with independent modules, nodes, what we're going to do is to divide the main hierarchy tree into small subtrees, right? Each small subtree is going to be like a black box in which everything is isolated and encapsulated unless you want to make something public. For example, public property. We will see an example of that later. So the way in which we create these isolated hierarchy trees is by attaching a shadow, and each Lightning Web component is going to be it is going to have a shadow attached. Okay, you don't have to worry about that as well. This is something that we do for you. Indeed, there are like two working modes for Lightning Web Components. We have a synthetic shadow and we have the real one, because some browsers didn't support the real one when we released the framework. But you don't have to worry about that, especially if you are starting with Lightning Web Components, right? Just bear in mind, this is a mechanism to make your components more secure. So with that, as promised, I want to start this from a practical approach. And for me, a practical approach is to take an app and build it from scratch. In this case, we're going to take an app that is part of our sample app gallery. We have a sample app gallery with more than 10 apps, all of them built in Lightning Web Components. All of them showcase other capabilities of the platform, of the Salesforce platform. Also, we have some things built on Heroku. So I strongly recommend you to take a look at the sample app gallery, because you are going to find very useful real-world use cases with their code that you can download, clone, and tweak to learn the language and the different Salesforce features. In this case, we have picked an app which is called Greenhouse App. This is a real estate app, and we have picked a page which is called Property Finder. In this page, users are able to look for houses that are being rented or sold, and they can there is a filters component in which they can enter the filter criteria as the number of bedrooms or bathrooms that the houses must have. And then we have another component on the right hand side, which is the one in which we show the search results, right? This is a page that we have built in App Builder, right? In App Builder, we have placed this component and we have placed this component. And there is another component which is going to be like an auxiliary one, this one, house style, that we are going to use to iterate over the different houses that are returned by the backend. So the first thing that you have to do when you want to work with Lightning Web Components is to configure your development environment. We recommend you to use Visual Studio Code, because we have released a set of extensions for Visual Studio Code that are going to make you super productive. We have extensions that perform auto-completion. We have extensions that give you direct access to the help when you hover, for example, over a component. We have extensions that give you linting capabilities. Well, a lot, right? So we strongly recommend you to use Visual Studio Code. Lightning Web Components cannot be created in the developer console, and you have to use a local development environment, but you will notice very soon the benefits of doing it that way, because you are going to be much more productive. Also, the way to deploy your code to your organizations could be any of the older methods, as for example using the Force.com migration tool. But we recommend to use the Salesforce CLI, because with the Salesforce CLI, again, you are going to be much more productive. With the Salesforce CLI, you can deploy code to scratchers, but also to non-scratchers as your developer or your sandbox, and that's the recommended approach and way to go. Also, when you are creating Lightning Web Components in your development environment, it's recommended to set up the debugging configuration in your org. I'm not going into the details of this, but you can check that blog that explains very well what to do. So we're going to build this page step by step. We have decided to divide it in steps that are meaningful, that contain small pieces of functionality that are complete, and that we can check the result when that step is finished. So the first step is going to be to create the house tile component, which is the smallest one and the simplest one. First, I'm going to show you the expected result. In this case, we just expect to have a component. This is a component that I have placed here with a builder that is going to show the different fields for a property record. But for now, we are not going to retrieve that record from the backend. We are going to create a fake property in memory in our JavaScript file. So when you create a Lightning component, normally it's going to be composed by 3 files. The first file is going to be the HTML file. The HTML file is a template. This comes from the HTML templates specification, and that's going to be the markup. It's going to contain the markup for your component. When that's finally rendered in your browser, if you take a look at the DOM, it's going to be something like this, right? The template keyword will be translated to the component name, but instead of on camel case, in kebab case. Then we're going to have a JavaScript file. The JavaScript file is going to be something similar to this code that we have here. As we can see, we are defining the component by using a JavaScript class. Again, this is something that is standard. It comes from the custom elements specification. If you remember, in that specification we were extending from HTML element. In this case, we will extend from Lightning element, but that class is not more than the HTML element class, standard class, with some more functionality to make it easier to work with Lightning Web Components. Also, that Lightning element class, we import it from the Lightning Web Components module, and the class that defines the components will be exported as well. If you remember, this comes from the ECMAScript 6 modules specification, nothing proprietary. Finally, if you are creating Lightning Web Components to be used on platform, on Salesforce, you will have to define a metadata file. It's the same as with any other metadata type. But by the way, Lightning Web Components can also be created off platform, and in that case, obviously, you won't need the metadata file. So we want to create this house tile markup, right? I'm going to show you the code, and I'm going to explain the different features of the framework making use of this code, okay? So this is the markup, the HTML file for the house tile component. Here you can see that it starts by the word template and it finishes by the word template, as we mentioned before. And this is the JavaScript file for the house tile component. In the JavaScript file, we have the same structure that we saw before, and we have something here which is a property. In Lightning Web Components, you define properties in the JavaScript file that then can be referenced in markup using the braces notation. This is really a JavaScript object that I'm making up here because I don't want to retrieve that information from the backend yet. When I retrieve that information from the backend, I'm going to have an object which has exactly this structure of fields, but for now I'm going to create a fake one. I'm going to say that this is the address, this is the city, etc., so that I can concentrate in creating just this small piece of functionality. So when you reference a property as this property, if this property is an object, then you can use the dot notation to reference all the fields. This will be familiar if you come from Visualforce. And also here we have another interesting thing, which is a getter. A getter is another way of defining a property, but in a getter you can compute some values or are some dynamic calculations that will be executed each time that the property is get, or each time that we reference that property in the markup. For example, we can reference that property in the markup in the same way that a normal property, right? And which calculation are we doing here? So this is a normal string concatenation. We are concatenating the background image URL string with the this.house.thumbnail property. What happens is that I'm using an ECMAScript 6 feature, but it will be exactly the same if I was adding the toString with a plus symbol. This means it's a reference to the class in which the property is defined. In Apex, you don't have to use this. For example, it's inherited, but in JavaScript you will have to use it. Indeed, if you are an Apex developer, most of the times you are going to forget about using this, and you are going to find out many times that you have made that mistake, but you fix it really quickly. Okay, and there's something else here. So we can see that there is a div, an h1, a p, all that standard, right? But then we are using something called line formatting number. What is this? Well, this is a component that we are using to show the price of the house formatted as a currency, right? This is a lining web component that belongs to our base component library. We know that because it's prepended by the word lining. And we are going to see that there are many pre-built components that you can reference into your code. These are web components, base components, UI components that we have created and that are available for you so that you can speed up your development process. This is the base component library, and instead of showing the slide, we're going to go to the library itself. And if you go to the component library, right, if you look for LWC library, you are going to find all the components that we have created. For example, I can go to the accordion one, and here you have all the documentation, the specification, and all the examples for all the different possibilities in which you can configure the accordion component. And here there's something that is very useful, which is a playground. So this is the code that is being used to render this component here, and you can change something here on real time, and it's going to be reflected the change in the component. So this is really useful if you want to play a bit with the components before using them into your code. Okay, so we have created this component, but there are still some tweaks that we want to do to its style, and we can do that through standard CSS. The only thing that you have to bear in mind regarding using CSS in Lightning Web Components is that, remember, each Lightning Web Component is like a black box because we are following the Shadow DOM specification. So the only CSS styles that will apply to your component or that will affect your component are those defined within the component. So any styles defined in a parent component, for example, won't affect the component, the child component, right? But the way of defining CSS is exactly the same one as in normal web pages. Also, I'm mentioning here the Lightning Design System. The Lightning Design System is our design system that contains all the definition of how, of which criteria do we follow to create Salesforce apps, which colors do we use, which UX patterns do we use. And also we have all our CSS classes available so that you can use them within your components. So for example, if you want to use that blue color that we are using in a specific menu, you can check our lighting design system, and instead of copying the color code, make a reference to our CSS classes. That way, if in the future we change the color slightly to a different blue, you will get that update for free, and your components are always going to look good within the Salesforce application. So in this case, we wanted to create custom CSS classes. So what you do is to create a CSS class. This is optional, and then you reference your CSS classes within your markup. This is exactly the same as in standard web pages. So we have done our first step. Let's go now to our house style list component. The house style list component is going to be the panel in which we represent all the properties that we retrieve from the backend, and we are going to retrieve those properties from the backend, iterate over them, and for each individual property, we are going to reuse our style component. We are going to pass in the information of each individual property, and we are going to let that component render our final property, right? But for now, instead of bringing all the properties from the backend, we are going to go step by step. We are going to create two fake properties. Instead of creating the fake property on the house style component, we are going to create two fake properties in the top level component, which is the house style list component, and we are going to perform an iteration. This would be the markup for our house style list component, and this is going to be the JavaScript file. As I say, for now, we are going to create a fake houses property. This time it's going to be an array. Why? Because when I implement the step that retrieves the houses from the backend, I'm going to receive an object which is an array of houses, right? But for now, let's do it this way. And the way that we have in Lightning Web Components to iterate over an array is by using a template directive. A template directive is an attribute that you can add to a template and to add dynamic behavior to it. And in this case, we are going to use the for each template directive that iterates over the houses property that we are referencing with the braces notation. And we are going to use another template directive for item to define a variable name that will hold each individual house during the iteration. So this means that the first time that we iterate over the houses property, the individual house will be this one, and the second time the individual house will be this one, right? In this case. Then you can reuse that individual house property within the body of your iteration, and you can treat each individual house independently. For example, we could access the individual house.address, individual house.city. Here we are accessing the individual house.id. But what we are going to do is to reuse our house style component because we created that in the previous step. We're going to reuse that component, and that component needs to receive each individual house on every iteration. And the way to do that in Lightning Web Components is by passing that information into an attribute that is going to correspond to a public property. That means if I have a parent component, in our case, I have the house style list component. And I have a child component, right? In our case, is the house style component. And I want to pass information down to that component. I can define a public property in the child component. The way to define a public property is by using a decorator called @API. Decorators are not exclusive from JavaScript. Decorators exists in other languages, as for example Python, and decorator is a design pattern as well. And they allow you to add functionality to the entity that is being decorated. In this case, it's a property, but it could be a method as well. So what we do, remember that it was our code for our house tile component. At the beginning, we were using a house property, but a fake property, right? But we don't want to do that anymore. What we want to do is to annotate that house property with the API decorator, so that a parent component can set the value of that property and can set the value of each individual property. That API decorator is something that you have to import from the Lightning Web Component module. Okay, so this is just the same code that we saw before. Is the house tile list component markup, but I just want to show you again that we are passing in the individual house property to the house API property that we have created in the child. Finally, this component is going to live in App Builder, right? And the way to configure components so that they are available in the different Salesforce experiences is by using the metadata file. In the metadata file, you can specify if you want the component to be available on a page in a builder, or in the utility bar, or for a quick action. There are many possibilities. Even you can be more restrictive and say, I just want this component to be available for account pages, or I just want this component to be available for mobile. You can configure them for different form factors. Okay, so with that, we are going to work now on our house filters component. Our house filters components, if you remember, this is what we are going to do now. Step 4. Come on, Wi-Fi. Okay. Here we are. Okay, so here we have our filters component. And in this filters component, you can write whatever. You can change the number of bedrooms, number of bathrooms. For now, this component is not connected to this component. They are completely disconnected. What we are going to implement is the markup. We are going to implement the behavior of being able to read what the user is inputting and selecting. And we are going to implement this reset button that resets the component inputs to 0. Okay, so this time we have a different thing, because before we had a parent component that wanted to send information to the child component, and now what we have is a parent component, our filters component, and child components that need to send me information of what the user is inputting. These child components are going to be a Lightning input and 2 Lightning sliders, 2 base components. I didn't have to implement them because they are already implemented, but these examples or these components are going to be useful to explain how this other pattern of sending information from a child to a parent works. So, for example, let's talk about this one, the input component. The input component is taking care of recording what the user inputs on that input field, right? And that component needs to pass to the filter components the value that the user has written. The way to do that in Lightning Web Components is by dispatching events. That means that there are different events that these components dispatches if you take a look at the documentation, but in this case we are going to use the change event. This is that we are going to react to any change that happens in that input search, any key that the user types. And the way to listen to that event in the parent component is going to be to define a handler. We are going to define a handler that does something when that event is listened. There are two ways to define handlers, dynamically and statically, but we are going to see the easiest one, which is to define it statically in the markup. Here, for example, we are defining an handler, I don't know if I say handler, but I wanted to say handler. We want to define a handler for the change event. So we are going to say that when this component Lightning input fires a change event on change, we are going to execute the code that is enclosed here. In this case, it's going to be a method that we have defined in the JavaScript file. If you see the syntax to reference methods is the same syntax than the one that we use to reference properties with the braces notation, and the methods must be defined in the JavaScript file. When you define an event handler, the event handler receives the event that has occurred as a parameter. And normally this event is going to have a payload with the information that the event is carrying. In our case, I know this because of the documentation. I didn't implement the Lightning input component, but I went to the documentation and I saw that in the value property of the event detail object is where the input that the user has written is being carried into the event, right? So what we do is that every time that we listen to that event, that means that any time that the user types something, we retrieve what the user has typed from this value property. And in our case, what we're going to do is to store that in a property here on the house filters components, because later on we will use those properties to send another event to the other component that we have on the page, the panel, the house style list components. But for now, we are going to just store that value so that we have the state stored at the top level component, which is the filters component. Great, so we have seen how to read the values of these inputs, but also we wanted to implement a reset behavior. This component lives on the filters component, right, the parent component, and this time what we want to do is to reset these components here. So the flow of the information is this time is going down, is going from the parent to the child. And remember that the way to do that is by having a public property that is surfaced as an attribute on the component, to which I can pass in a value. So again, this is something that I didn't have to implement in the child because those components are base components already implemented, but I know that in the implementation of that component there must be an API property called value, because I'm able to pass in a value to that. And I read that and I learned that from the documentation, right? So what we are going to do is we have a Lightning button, another base component, and when that button is clicked, bear in mind this is another handler for the click event, so the Lightning button is sending us information. We are going to reset the value of those properties. Here I should have the rest of the code that we had in the previous slide, but for simplicity I'm just showing you the pieces of code that are relevant on each moment. So here, when the button is clicked, I want to set the properties to 0 or to empty. And what happens is that here I'm able to bind those properties to the value attribute in the different inputs and pass the information down to those base components. So we have been able to create our filters component. We have our house stylist component. The next step is going to be to make our house stylist components retrieve the properties or the houses from the backend. This is going to be step 5. And for now, bear in mind, we are not communicating this component with this component yet. We are just implementing the behavior on this component to retrieve properties from the backend, and we are not filtering yet but by any of these criteria. We are retrieving all the existing properties. In my case, I have 10 properties, right? So, when you want to work with Salesforce data, with records that you have in Salesforce, or to create records in Salesforce, there are 2 ways to do that in Lightning Web Components. The most efficient way is to use the Lightning Data Service, which is a service for which you don't need to use Apex. However, when you work with multiple records, at the moment the only adapter that we have for Lightning Data Service is on beta. So for now, I would recommend you to use the Apex approach. The Apex approach would be to create an Apex method that returns the records that you want to show, or that performs the operations that you want to perform, and then you have to call that Apex method from your Lightning Web Components. There are 2 ways to call those Apex methods, but we are going to see the one that is less straightforward and that I think is most interesting for people who's learning, right? For creating your Apex method, the only thing that you have to bear in mind is that you must annotate the method with OR enabled. And if your method is reading data, you can mark your method as cacheable. If you mark your method as cacheable, that means that the results of that Apex invocation is going to be stored on a client-side cache. That way, if on a later moment you need to perform the same invocation, the records are going to be retrieved from the client-side cache, and the server trip is going to be avoided. That way your components are going to be much more performant. But again, this is something that you can use only when you don't use DML, right? So the way in which we are going to see here how to call Apex is by using the wire service. You can do the other ways to perform a one-time invocation, invoking Apex imperatively, but by using the wire service, what you can do is to create a service that reacts to changes in the variables that you indicate, and that calls your Apex method anytime that those variables change. That's what we want to do, because we want to retrieve new values each time that this filter criteria changes, right? So when you want to invoke Apex, you have to import your Apex method in this way. And then, if you are going to use the wire service, what you use is another decorator called wire that you import from the LWC module. And with this, you are declaring the wire service to use the Apex method, or to invoke the Apex method anytime that any of these parameters change. We are indicating that by using the dollar character before the name of the property, right? And every time that the Apex method is invoked by the wire service will take care of that. We don't have to do anything but changing the values of the properties. The result will be stored in the property that is being decorated. This time we are decorating the houses property with the wire decorator and all these parameters, right? What happens that as we have annotated our method as cacheable, it may happen that the results are on the client cache, and it may happen that the wire service retrieves these records from the cache or from the server if they are not there. That's super convenient. And finally, the step that we are missing to finalize our application is to communicate the filter criteria to the house style list component, because we were retrieving all the houses without any criteria, but now we want to filter by the filter criteria that the user is typing at any time, right? So I'm going to show you the final result. Sorry, I cannot. Yeah, like this. And this is the final result for our application. Let's see if my internet connection let me show it to you. But basically what we are going to see is how changing a value on the filter is reflected on the panel on the right hand side. For example, if I write here Victorian, this is going to filter by Victorian houses when internet allows me to do it. Come on. Okay, so it's filter, right? When we change the number of bedrooms, for example, it's going to filter as well. Normally this is immediate. What happens is that I have a very bad internet connection these days, right? And this way we are going to show the different houses that are retrieved thanks to the wire service. So we are not performing that invocation. The wire service is retrieving them. We're going to perform that communication using a beta feature which is called Lightning Message Service. The Lightning Message Service is going to allow me to communicate components that live in different DOM hierarchies in the page. So this component here is going to communicate with this component here. The page has been composed with a builder, and they are going to be able to communicate thanks to the Lightning Message Service. And the Lightning Message Service is going to work also if you have Aura components, if you have Visualforce components that you want to communicate between each other. So it's really powerful because a lot of use cases are supported. Even if you have components on the utility bar, that's supported as well. To use the Lightning Message Service, what you do is to create a message channel. The message channel is going to be a new metadata type in which you define the structure of the events that are going to be published into that message channel. In this case, our messages are going to contain the search key, number bedrooms, and number bathrooms. And then you define publishers for that message channel and subscribers. It follows a publish-subscribe model. This is in beta in Spring 20. This is the only beta feature that we have seen in the talk. So how do we define a publisher for that message channel? Our publisher is going to be the house filters component, right? So what we do is to import the message channel. We also import a couple of things from the Lightning Message Service library. And we use the publish function. This is one of the functions that we have imported from that library. The publish function will be invoked anytime, in our case, anytime that each of the filters changes, because we want to send an event anytime that we detect a change on the search key or the number of bedrooms or the number of bathrooms. Then you define in which message channel do you want to publish the event, and then you define the payload for the event. In this case, we want to carry all that information. What about the subscriber? Our house style list component is going to be a subscriber, and it's very similar. We import the message channel. We import the subscribe function, and then we create a subscription in this way. We say that we want to subscribe to this message channel, and we want to execute this function when a message is listened. The function is called handle filter change I don't have the function here because the class is longer, but we are going to go to the GitHub repo. This code is available for you. I will share the URL of the repo at the end of the talk in case that you want to take a look. And here we can see the full code. So we define the handle filter change method, or we say that this is the method that we want to execute every time that a message is listened. And this method is going to read the payload of the message and store that into properties that belong to this component. Search key, number buttons, and number buttons, these properties here. So what happens when I make a change on one of these properties? That as I'm passing those properties to the wire service is going to react and is going to bring new data from the backend or from the client cache. So all the cycle is complete, all the code sticks together, and now we have finished our application that is using a lot of the new capabilities of the Lightning Web Components framework, and that is going to be super performant because it has caching capabilities implemented, and also very easy to extend and to use in other applications thanks to our publish subscribe model and the use of events. So we have arrived to the end of the talk. I hope that you enjoy it. Here you have the code of the talk if you want to take a look. Also, I recommend you to take a look at this Trailhead module. Trail, which contains many modules related to Lightning Web Components development. And also I recommend you to take a look at the sample app gallery, especially interesting the Lightning Web Components recipes repo, because in that one we have easy to digest recipes, short examples of how to implement certain patterns in Lightning Web Components. And here you have a couple of more links. Thank you so much, and I hope that you enjoyed the talk. If you want to follow me on Twitter, my Twitter handle is albasfdc, and I will respond any question that you have. Thank you.